Surrounding our planet are some truly enormous celestial bodies. Jupiter, the largest planet in the solar system, is so big more than 1,300 Earths could fit inside of it. Our star, the Sun, dwarfs everything close by, and not just in sheer size, it also holds 99.8% of the entire solar system's mass. Compared to us, celestial bodies such as these are immensely large. But when we look out across the observable universe, the objects in our solar system pale in comparison to some of the wonders that we have discovered so far. Out there exist objects and structures so large that their magnitude defies comprehension. So are you ready to achieve the impossible? To travel faster than the speed of light and explore the true titans of the cosmos? Rox S42b is so large in fact that it sits on the edge as to whether it should be classified as a planet or a failed star, known as a brown dwarf. Brown dwarfs are essentially stars that didn't gain enough mass to kickstart nuclear fusion in their cores. To be classed as such, these objects must be at least 13 times the mass of Jupiter. But Rox S42b is 9 times the mass, technically making it a giant planet on the limit. Although this planet is a behemoth, it is nothing when compared to the very thing it could have been. Now, we must take this journey to the next level and travel 160,000 light years away to a neighbouring satellite galaxy called the Large Magellanic Cloud. Here, we will find the current largest star in the known universe. This is WOH G64. A colossal star that is estimated to be around 1,540 times the radius of the Sun. If this star were at the centre of our solar system, it would engulf the orbits of Mercury, Venus, Earth, Mars, and even Jupiter. These types of stars have exhausted their nuclear fuel, leading to the expansion of their outer layers, transforming them into true cosmic giants. It is classed as a red supergiant, and as you can see, its immense size and intense gravitational forces cause it to distort, rendering its shape more like a giant cloud than a sphere. You may think that to become so large, it must be extremely old, but WOH G64 is likely only a few million years old, unlike the Sun, which is around 5 billion years old. WOH G64 is in the latter stages of its stellar evolution, and almost certainly is not going to fade away quietly. Eventually, gravity will win, and its core will collapse once and for all, causing a supernova event. One that leaves behind either a neutron star or a black hole. Such titanic stars, it seems, live bright, yet short lives. Although this star is a true cosmic giant, it is nothing when compared to our next location. Now we must travel 8.61 billion light years away to one of the most massive galaxy clusters known, the Phoenix Cluster, because at the centre of this collection of magnificent galaxies is where we will find the largest black hole in the known universe. This is Phoenix A. An object potentially so extreme that it makes supermassive black holes seem placid. Phoenix A is possibly so large that it puts it within a new category, a stupendously large black hole. Models suggest that this black hole could be 100 billion times the mass of the Sun. That's 100 billion suns all crammed into one. This immense object would be nearly 25,000 times the mass of Sagittarius A star at the centre of our galaxy, the Milky Way. It would be greater than the mass of the entire Triangulum galaxy combined, possibly 4 times over. And if it were placed at the centre of our solar system, it would engulf every planet, the Kuiper Belt, the Oort cloud, and beyond. In fact, if you could travel around it at the speed of light, it would take 71 days and 14 hours to complete just one loop. How a colossal object like this grows to be so large is a mystery, but it could be the result of many black holes merging to create one titanic black hole. And incredibly, it is still growing, devouring matter at a rate of 60 million suns a year. This could well be the largest single celestial body in the observable universe. For our next location, we must travel back to our neighbouring satellite galaxy, the Large Magellanic Cloud, because it is there that the largest known nebula can be found, a magnificent place of frenzied starbirth. This is the Tarantula Nebula, a stellar nursery of gas and dust that spans an area more than 600 light years. It is so large that if it were at the same distance as the Orion Nebula in the Milky Way, we would be able to see it during the day, covering a quarter of our sky. As you can see, within this region many big bright stars are clustered together. These stellar inhabitants are young, likely only a couple of million years old, and are made up by some of the most massive stars known, each about 100 times the mass of the Sun. It is these stars that are cutting cavities into the surrounding material that once gave birth to them, creating these magnificent dusty filaments as they release torrents of ultraviolet light, giving the area its famous nickname, the Tarantula Nebula. Why this region is churning out stars at a furious pace is a mystery, but it may be the result of the galaxy it is located within, the Large Magellanic Cloud, interacting with the Milky Way, causing an episode of energetic star formation. And so, the next location is set. Now we must travel to a supergiant, the largest galaxy in the observable universe. A journey of 654 million light years. This is ESO 383-76, an extremely luminous supergiant elliptical galaxy that has an estimated diameter of 1,760,000 light years, making it nearly 20 times the diameter of the Milky Way and even 3.5 times that of its predecessor IC 1101. This titanic galaxy is packed full of trillions of stars, many of which were likely born within spiral galaxies that merged to create this cosmic behemoth. A behemoth that is, however, now devoid of any new star formation. Although not on the same scale, this is the future of our galaxy. In about 4.5 billion years from now, the Milky Way and Andromeda will collide and merge, becoming one giant elliptical galaxy similar to this. One day in the far future, the magnificent spiral structures that we have all become so used to seeing scattered through the cosmos thanks to our space telescopes will be no more. Only these enormous smudges of light will be visible. Of course, when it comes to the largest objects in the universe, we can only visit those that we have already discovered. Somewhere out there, there are likely even larger galaxies or black holes, even bigger planets and stars. If we go to the next level, then there are of course clusters of galaxies, such as El Gordo, which means the fat one in Spanish, that is estimated to be between 10 and 30 million light years in diameter, weighing in at 2.1 quadrillion times that of the Sun. There is the largest known structure in the observable universe, the Hercules Corona Borealis Great Wall, a galaxy filament that stretches an estimated 10 billion light years in length. And then of course there are supervoids.